Hello everyone, this is Miss Din's lesson on grade 8 math. This is the third video on factoring polynomials. So ready your notes, ready your pens as we go through learning factoring polynomials. Now before anything else, I would like to remind you that there are some instances that I would be asking questions. And if it comes, I would like you to pause the video, think over of what could be the answer, and then pause when you're ready to proceed. This time, we will focus on factoring difference of two squares. Are you ready? Before proceeding on our main topic, let's recall on some prerequisite terms. First, let's have perfect square. A perfect square is a resulting product of a number multiplied to itself. For example, 2 multiplied to 2, the answer is 4. Negative 2 multiplied to negative 2, the answer is 4. Now 4 here is what we call a perfect square. Notice that whether the number multiplied to itself is positive or negative, the answer is still 4. Therefore, a perfect square is always a positive number. Some of the perfect squares are 1, 9, 16, 25, 36, 49, 64, 81, 100, and so on. Second, square root. Now a square root is a number which produces a specified quantity when multiplied by itself. 4 multiplied to 4, the answer is 16. And 4 here that is multiplied to itself is what we call a square root of 16. Now notice there is no square root that is a negative number. Now how about perfect square and square roots of variable? Now a variable is a perfect square if it has an exponent divisible by 2. So let's have a multiplied to a, the answer is a squared. A cubed multiplied to a cubed, the answer is a to the power of 6. So a squared here and a to the power of 6 are what we call a perfect square, because in a squared, the exponent 2 is divisible by 2, as well as a to the power of 6, the exponent 6 is also divisible by 2. Remember, in order to get the square root of a variable, simply copy the base and divide the exponent by 2. So, in order to get the square root of a squared, we divide the exponent 2 by 2, and that is 1. A to the power of 1 is simply a. And a to the power of 6, we divide the exponent 6 with 2, the answer is 3. So the square root of a to the power of 6 is a cubed. Notice these are the numbers that are Notice that these are the variables that are multiplied to itself. So how to factor difference of two squares? Let us observe the given pattern. A squared minus b squared is equal to the quantity of a plus b multiplied with the quantity of a minus b. Notice that the polynomial a squared minus b squared, the first term as well as the second term, are all perfect squares, and the operation used is subtraction. Therefore, the polynomial a squared minus b squared is indeed a difference of two squares. Now, look at the factored form. It's the quantity of a plus b multiplied with the quantity of a minus b. How did we get this pattern? Remember that factoring is the reverse of multiplication. Can you still remember FOIL method? F for first, O for outside, I for inside, and L for last. We use this when we multiply two binomials. For example, we have a minus b multiplied to a plus b. First, we multiply a times a, and that is a squared. Then we multiply a times b, and that is positive ab. Next, we have negative b times a, that is negative ab. Then lastly, negative b times positive b, and that is negative b squared. Notice that positive ab minus ab is 0, so we can cancel these two. Therefore, the final answer is a squared minus b squared, which is the polynomial with a difference of two squares. And so the pattern a squared minus b squared equals the quantity of a plus b multiplied with the quantity a minus b is being formed. With this, we just created the following steps. First, prepare two sets of parentheses for the two factors. Second, get the square roots of the first and second term. Third, write them as sum and difference inside the parentheses. We will be having these four polynomials as our examples. Let's try factoring m to the power of 6 minus 64. Let's check first if the given polynomial is indeed a difference of two squares. First, m to the power of 6. M to the power of 6 is a perfect square, since the exponent 6 can be divided by 2. 64 is also a perfect square, since 64 is a product of 8 times 8, and the operation used is subtraction. Let's get first the square root of m to the power of 6. So that's m to the power of 6 divided by 2. 6 divided by 2 is 3. Next, the square root of 64. We know that 64 is 8 times 8. Therefore, the square root of 64 is simply 8. So therefore, let's proceed on making the two sets of parentheses. Let's write first the square root of m to the power of 6, which is m to the power of 3, and the square root of 64, which is 8, and then write it as a sum, plus, and difference or minus. So therefore, m cubed plus 8 multiplied with the quantity of m cubed minus 8 is our factored form. So let's try factoring 4a squared minus 1. The first term 4a squared. Let's see if it is a perfect square. 4 is a product of 2 times 2, so it is a perfect square. A squared, the exponent 2 is divisible by 2, so that is also a perfect square. The second term 1 is also a perfect square as it is a product of 1 times 1, and the middle sign is minus. So let's proceed. Square root of 4a squared. We know that 4 is 2 times 2, so the square root is 2. A squared, the exponent 2 divided by 2 is 1, so a to the power of 1 is simply a, and square root of 1 is simply 1. So the factored form is 2a, 1, then plus and minus. So let's try factoring a squared b to the power of 6 minus 16c to the power of 4. Notice that the first and second term are perfect squares, and the middle sign is minus. So let's have the square root of a squared b to the power of 6, and that is a b to the power of 3. Then the square root of 16c to the power of 4. We know that 16 is 4 times 4, so the square root is 4, and c to the power of 4 is c squared. Therefore, the factored form is a b cubed plus 4c squared multiplied with the quantity of ab cubed minus 4c squared. Lastly, let's factor 25m to the power of 4 n to the power of 5 minus 4n. Notice that 25 is a perfect square, m to the power of 4 is a perfect square, 4 is a perfect square, but n to the power of 5 and n are not. Therefore, this is not a difference of two squares. But notice, n to the power of 5 and n, the variable n, is being repeated. Remember in our previous lesson that in factoring polynomials, let's check first if there are any common factors. So since there is a common factor, so let's use the GCMF. So using GCMF, the GCMF is n. So when we factored out n, the remaining quotient is 25 m to the power of 4 n to the power of 4 minus 4. And as you notice, the quotient is a difference of two squares. So since it is a difference of two squares, let's factor the quotient. The square root of 25 is 5. The square root of m to the power of 4 is m squared. The square root of n to the power of 4 is n squared. And the square root of 4 is 2. So the complete factor is n, which was the GCMF. Then, enclose in the two parentheses, 5m squared n squared plus 2, and here 5m squared n squared minus 2. Notice there are three factors. First, we have the GCMF and we have the two factors of the difference of two squares. Do you now understand how to factor difference of two squares? Now let's apply what you've learned. Which of the following is the factor of the given polynomial e squared minus 1? You are given two choices. Try it on your own. Pause. Do you have the answer now? Correct. It's the quantity of e plus 1 multiplied with the quantity of e minus 1. The square root of e squared is e. The square root of 1 is still 1. Next, which of the following is the factor of the given polynomial? A to the power of 6 b squared minus 9. You are given two choices. Try it on your own. Pause. Do you have the answer now? Correct. It's the quantity of a cubed b plus 3 multiplied with the quantity of a cubed b minus 3. Lastly, which is the factored form of the given polynomial 16x squared y to the power of 4 minus 25 is z to the power of 6? You are given two choices. Think it over. Pause. Do you have the answer? Correct. It's the quantity of 4x y squared plus 5z cubed multiplied with the quantity of 4x y squared minus 5z cubed. Always remember, before using any other methods of factoring, check first if there are any common factors and use GCMF, just like what we had in our fourth example. Then the pattern a squared minus b squared equals the quantity of a plus b multiplied with the quantity of a minus b can only be used if there is a difference of two terms that are perfect squares. Thank you so much for learning through with me on factoring difference of two squares. Did you take notes? Did you understand? Do you have any confusion? If you have, don't be shy to type it on the comments.